download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support, and so much more. This video is called the development of the periodic table. Now, just like with the atom, if I asked you to picture the periodic table, we'd all be picturing a very similar table. However, the periodic table has not always looked like what we know it to look like now, and it has changed over time due to lots of different discoveries. So, for example, here is an example of an early periodic table. Until recently, there were two obvious ways to classify elements and to order them. One in terms of their physical and chemical properties, and another in terms of their relative atomic mass. That is to begin with. Scientists didn't know much about the atomic structure, so they didn't know about protons, neutrons, and electrons. And there was no such thing as atomic number, which we know that they're ordered in now. Before the 20th century, the only thing, therefore, that scientists could measure was the relative atomic mass. So early periodic tables were arranged in terms of their relative atomic mass, with obviously the smaller masses starting out and then the masses getting bigger as the table goes on. When this was done, a periodic pattern was noticed in terms of the properties of the elements. The properties repeated at regular intervals, and this is where the name periodic table comes from. Now, the issue is, when they were first arranged, not all elements had been discovered. So earlier periodic tables like this were incomplete. As you can see, there are many elements that aren't there that you'll see in a modern periodic table. In addition, those elements that had been discovered were placed in order of the relative atomic mass, as you can see here. So some ended up in the wrong group, and we'll get to why that is in a second. Now, that's where a guy called Dimitri Mendeleev came in, and he actually overcame lots of these problems. At the time, Mendeleev designed his periodic table, and only 57 elements had been discovered. Now, what did he do differently? Well, he put the elements mainly in order of atomic mass, like the early periodic tables. However, what he also did is he changed the order of some of the elements if the properties meant that it should be changed. So, for example, a really good example to use here was beryllium and iodine. Now, beryllium has a greater atomic mass than iodine and therefore should be further up the table. They should have been swapped positions. However, what Mendeleev noticed was that iodine acted very, very similar to bromine, chlorine and fluorine, and therefore that they should be in the same group. And therefore he swapped the order. So it's important to understand that in terms of Mendeleev's table, they are mostly ordered in atomic mass, with hydrogen obviously being the less, and then they order an atomic mass this way. So as they go up, the atomic mass increases. However, he ordered them in terms of their properties as well, and swapped properties if it meant that the properties should make it in a different group. And a second very clever thing that Mendeleev did was he left gaps in the table to make sure that elements with similar properties stayed in the same groups. Now, for example, you can see that here, so where he left gaps. Now, these gaps actually indicated the existence of undiscovered elements. Now, the reason, remember, he left the gaps is because of the groups, and he put elements into the group in which they belong, which meant that gaps were left. Now, as we just said, some of these gaps indicated the existence of undiscovered elements and allowed Mendeleev to predict what their properties might be. So, for example, we have an element that's missing here. Now, Mendeleev could therefore predict that this property, when discovered, will have similar properties to the other elements in the same group. Okay, and that's exactly what happened. When the elements were found and their properties were studied, Mendeleev's predictions were correct, and it helped confirm his ideas. So, for example, Mendeleev made a really good prediction about the chemical and physical properties of an element called silicon, which we know today as germanium. And he was able to do this because he left the gaps in the periodic table, and the gaps were for the elements that were undiscovered, and these would have similar properties to that in the group that it fit in. Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers and so much more. The link is in the description. Now, finally, you need to understand that the discovery of isotopes confirmed Mendeleev was correct to swap elements. So, for example, when we look at our beryllium and our iodine, we can see here the greater mass in beryllium, but that is caused by the isotopes of beryllium. Okay, the isotopes, remember, change that average of atomic mass, and the discovery of isotopes in the earlier 20th century confirmed that Mendeleev was correct. Okay, it's because isotopes of the same element have different atomic masses but have the same chemical properties, so occupy the same position on the periodic table. Okay, it's now important to understand that the modern periodic table is arranged in terms of its atomic number, which we now know to be the amount of protons that you found. Okay, so really what we've got to understand from this video is that elements were first classified by their atomic weight before the discovery of subatomic particles like protons, neutrons and electrons. Okay, so mainly they were arranged in terms of their atomic weight or atomic mass. The first periodic tables were incomplete and elements were often placed into wrong groups because of the undiscovered elements and also because of isotopes and the atomic mass. We also need to understand that Mendeleev solved these issues because firstly he swapped the order of some elements, so for example beryllium and iodine, and secondly he left gaps for undiscovered elements. And then we've also got to understand that the discovery of isotopes supported Mendeleev's periodic table and his ordering. Now here are some summary questions. Pause the video to have a go. Okay, so in the early 1800s, elements were arranged mainly by their atomic mass. In early periodic tables, some elements were unknown. What did this lead to? Well, this led to elements being placed into the wrong group. What did Mendeleev do differently with his periodic table? Well, number one, he left gaps. And number two, he reordered certain elements based on the properties. Gaps left by Mendeleev allowed him to predict what? Well, undiscovered elements. So the undiscovered elements were predicted due to the gaps. The discovery of what confirmed that Mendeleev was correct not to order the elements in terms of atomic mass. The discovery of isotopes. And then state two changes Mendeleev made to his periodic table. Well, one in terms of the reordering of elements based on, of course, the properties. And two, he left gaps for the undiscovered elements. So we've now looked at a video on the development of the periodic table. There are plenty more practice questions on the website, and as ever, if there's anything you didn't understand, get in contact with a tutor who will happily help.